Stella? Stella? Where is that dog? Stella? I found her, Al. Hey, what's up? It's Nate. This is Stella. She belongs to my neighbor, Al. She likes to wander. Al asked me to help him install an underground dog fence. He wants to provide Stella with plenty of room to run, but still keep her within his yard. Come on. We can use this to learn about finding the maximum area of a fixed perimeter and unleash another problem solved. Here is the system Al purchased. It includes 500 feet of fence. So, 500 feet is the perimeter, or the total length of the fence. He wanted to fence in a rectangular region, and he wanted Stella to have as much area as possible. That's where I come in. Earlier today, I helped Al find the maximum area of a rectangle using 500 feet of wire. We started by exploring some possible rectangles with a fixed perimeter of 500 feet. First, we made the width 50 feet. These two sides will use 100 feet of fencing. With 400 feet of fencing left, each of these sides must be 200 feet. Together, these two sides measure 250 feet, which is half the perimeter. As you know, the area of a rectangle is found by multiplying width and length. 50 feet times 200 feet equals 10,000 square feet. Still, we thought we could do better. Next, we tried making the width 25 feet. We know that half of the perimeter is 250 feet, so the length must be 250 feet minus 25 feet, or 225 feet. The area is 5,625 square feet. Interesting! The perimeter is still 500 feet, but the area is smaller than the area of the first rectangle. What if the width is 75 feet and the length is 175 feet? The area is 13,125 square feet. This is considerably larger. But was this the largest possible area? Stella could be full grown before we figure out the fencing. Don't worry, we found another way to make sense of it. We organized our work by putting the information into a table. The next rectangle we tried measured 100 feet by 150 feet. Do you notice the pattern? The closer the measurements of the width and the length are to each other, the larger the area. What would happen if the width and length were equal? That would be a square. Is a square a rectangle? A rectangle is a quadrilateral with four 90-degree angles. A square has four 90-degree angles, so a square is also a rectangle. The area of the square is the largest we've found. Could there be a rectangle with a larger area? Al and I decided to continue our table to find out for sure. We tried a width of 126 feet, and the area was smaller than the area of the square. Then we tried one more rectangle measuring 124 feet by 126 feet. It has the same area. This rectangle is congruent to the one measuring 126 feet by 124 feet. Switching the dimensions of a rectangle does not change the area. We can also make sense of this by looking at a graph. The x-axis is the width of the rectangle, and the y-axis is the area. Graphing the results allows us to see how the total area increases as the width increases. To the point of maximum area. After that point, the total area decreases even though the width increases. Our graph just shows some rectangles with a perimeter of 500 feet. If we show all possible rectangles, this is what our graph looks like. For example, we could have a rectangle that measures 10½ feet by 239½ feet. There are actually an infinite number of rectangles possible. All of these rectangles have the same perimeter, but different areas. The area of our fenced-in yard gets larger as we make it more like a square. The longer and thinner the rectangle, the smaller the area. Now that we've found the largest area for Stella, we just need to show her the new limits. Problem solved. Good girl.